Okay, this is our analog to digital converter. Right here we have the CD4007 transmission gate. And right here we have a PECL operating as a comparator. So the PECL is hooked up in this manner. There's a current source up here. There's two PNPs. The R2R ladder ramps into there. We've got the capacitor input. I had to buffer the capacitor input with an emitter follower right there. As this voltage goes up and passes the reference voltage, this voltage goes down. Voltage going down goes into an inverter, which puts it up. And this is our compare signal. So right here is we're injecting a triangular waveform into our analog digital converter. So right here I can change the type of the waveform. And right here we're looking at the output of the R2R ladder. So let's take a closer look at that. Oops, I don't want that. So right here we're putting in 4.39 volts. So as I go down, you can see the R2R ladder's output. And it's doing a binary search. You can see it approximating. Okay, so while that's cool, let's figure out how fast we can run this ADC at. So this is the output of our DAC, which is just writing what it reads and putting it into the DAC. So right now we've got a sine wave and it's AC coupled, so let's trigger off the wave gen. Okay, so I'm going to use an FFT to, so technically aliasing, well, the max frequency is when aliasing occurs. So when the main harmonic overlaps with its periodic harmonic, then we will have aliasing. So let's see how that works. So we can see them diverging. Oops, I overshot it. We found that it aliases around 150 hertz. Right there. And we can see it start aliasing right there. We get a slower frequency out. It's not surprising because our ISR triggers every 3 milliseconds. And the frequency of 3 milliseconds is 333 hertz, and 333 hertz divided by 2 is 166 hertz. So it's no surprise that it starts aliasing, about 160 hertz. Alright, that's all I got.